right? 3 over 1. Damn. Okay guys, welcome to another video, and today I'm going to solve this integral that I took from qualification to MIT Integration V 2025. When we are dealing with this integral, we should first take out this x from its roots, so here if I take out this x here, the first one, I know that is the power of 1, so it becomes 1 over this, right? Then I get times x, this x, it's also to the power of 1, so we get, now we are going to multiply these ones, 4 over 2 times 3 over 1, right? Good. Then we multiply, we go with this, it's 1, right? We get 5 over 3 times 4 over 2 times 3 over 1. We can move on, as here it's going to infinity. Here the bottom line is to find its pattern, only that. I can say that it's 1 over, now I can get 6 over 4, right, times this 4 over 2, this and this, and I'm going to put like this as it's go to infinity. So this integral is equal to what? First it's x, right? We get 1 over 3 times, we get this 1 over 2, right? And then I get 3 times 2 times 1 over 6 4 3. Then we get x here, 4 3 2 1. Guys, I don't know whether you have seen a pattern here in the numerator. I hope you have. It's factorial. It's this that I wanted, but now I want this. But relax a bit. First I need to do something really quick. Now I can add the exponents as it's x. I got this, right? It's 1, yeah, it's 4, yeah, it's factorial, 2 factorial, yeah, it's 3 factorial, but I'm going to write like this, plus here is 4 factorial, let me do like this, yeah, 2 1, then we get this, but in the denominator, how is it, the pattern? Yeah, let's think a bit here to find the pattern in the denominator. For example, we all know that here we have 2 factorial, 2 factorial, 4 factorial. So there we have what? We have n factorial, right? Numerator, only in the numerator. Now denominator, what we get? If you think a bit, you'll get on this point here, in this conclusion. Your conclusion will be this, that we have n plus 2 factorial. For example, when we take n, it's equal to 1. Yeah, it's 1, right? Then here we get 3 factorial. 3 factorial, for example, is 3 times 2 times 1. 1 doesn't matter at all here. But I don't have 2 here. That's why I'm going to put 2. If we let, so that I can cancel out this and this, and we get this. And we let n equal to 2. We get 2. Yeah, we get, it's 2 here. 2 factorial. Then we get, when we plug in 2 here, we get 4 factorial. 4 factorial, we know that it's 4 times what? Times 3 times 2 factorial. 2 factorial is 2. So we get 4 times 3 here in the denominator. 4 times 3. And this 2 here will be cancelled by this. So I've just found its pattern here. So I can come here and write like this. This integral here. Yeah, it's x to the power of what? I'm going to sum this. The sum of 2 n factorial over n plus 2 factorial, and starts from 1 and goes to infinity because of this. And don't forget the x. Now another big deal here is to find the sum of this. Okay. We can, as it's just a constant, it doesn't matter. I can write like this. It's x to the power of 2, the sum of n, yeah, it's infinity, n factorial, n plus 2 factorial. Basically, I want this sum here. Let's go here, let's come here. Infinity, n is equal to 1. Then we have n factorial here, n plus 2 factorial. To evaluate it very easily, I'm going to say k and goes to infinity. Here, instead of writing infinity, I'm going to write k. Here it's n, it's equal to 1, n factorial here. Then n plus 2 factorial. Now, we need to simplify this. We get n plus 2 factorial, it's equal to n plus n factorial. Here we can write n plus 1, right? N plus 2 times, oh my god, yeah, it's basically like this. N factorial, n plus 2, and yeah, it's this. Get what here? Get 1 over n plus 1 n plus 2 here. So basically it's this. We get this. Now we have infinity here. The sum here, it's k and it's equal to 1. Now we can write like this. It's n plus 1 n plus 2. Now we need to do partial fraction here to evaluate its sum here. And how would it be? This, for example, let's come here. It's this, right? N plus 1. Now we need to do this first of all, and we get it's n plus 1. Here it's a, here it's b. Let's consider b here. N plus 2. Guys, if you don't know partial fraction, I hope you watch is black pen red pen videos. Yeah, it'll give you some tricks to evaluate this kind here very quickly, but I'm not going to use this trick right now. For example, let's add this, right? If we add this, we get the same denominator, but yeah, numerator we don't get. So I'm not going to work in terms of denominator here. I won't use them. I'm going to use 1. It's 1 will be, if we sum this, we get a n plus 2 plus b here and plus 1, right? If we move on, there's no need. For example, when it's n here, we get a plus b, it's equal to 0. Why 0? Because we have 0 n here, so that's why that equals to 0. And here when n is to the power of 1, because here is to the power of 1, right? It's 2a plus b, it's equal to 1. And here I get that 1 is equal to minus b, and I can take this minus b, plug in here, and I get minus 2b plus b, it's equal to 1. So what I get here, it's b, it's equal to minus 1, and a, it's equal to 1. Only this. Okay, we get a, it's 1, b, it's minus 1, so we can come back here to this limit here. Basically it's a sum, and I can write like this. It's k and it's equal to infinity. It's k here and it's equal to 1. Then by partial fraction we concluded that it's 1 over this minus, because it's b here, 1 n plus 2. If you try to sum them, you'll get here, right? Okay, from now on we can use this telescopic sum, but I don't like that, so as it's my video, we are going to use my method. Now I get this limit here, it's k when it goes to infinity. Now I want the sum here. When n is equal to 1, we get 1 over 2, right? Here we get 1 over 3 plus, when n is equal to 2, we get 3 minus, it's 4, right? Plus, when n here it's equal to 3, we get 4, right? And we get, it's, yeah, we get 3, yeah, we get 5 plus infinity. Just kidding. When n is equal to k minus 1, if we plug in a k minus 1, we get 1 over k minus 1 over k plus 1. And the last term, of course, when n is equal to k, we get 1 over k plus 1 minus 1 over k plus 2. Now we can cancel out this and this. Look, that a negative will be cancelled by the next number. Of course, here minus 1 over 5, it will be cancelled by a number that is here, right? And the negative 1 will be cancelled by the next number, as I've just said. This, and the positive, the number before it, this will be cancelled in number. There is a number here, as we see it's positive, it will be cancelled by a negative number before it. And this, of course, needs to be the next number to be cancelled. So the final result of this limit here, it's what? It approaches infinity. Here we get 0, so the final result is 1 over 2. So there is the sum here, it's equal to 1 over 2. So I can come here to my integral that is missing the x, and I can write like this. It's x to the power of 2 times this sum here, that's equal to 1 over 2 dx. You can cancel this and this, and we get this integral. And guys, that's the end of the video. Bye. I won't solve this. That's for real, I won't solve it.